Welcome to second module video lecture on basics of civil and mechanical engineering. In this second module, we are going to deal with the selection of a site, different types of foundation we are using in the field, and then brick masonry, stone masonry, and then green buildings, as well as different types of interior designs. So first thing we are going to see in this first video lecture is selection of a site. In this selection of a site, certain parameters we are going to follow. First parameter is soil at the building site should not be made up of soil. So what does that mean? Soil at building site should not be made up of soil. So the soil should not be artificially filled in that particular site. The existing soil layer is enough. And second parameter is building constructed over such soil may undergo differential settlement. Site should not be an undulated ground. Site should have its general slope for easy drainage. Civic services such as main water supply, electrical lines, telephone lines, drainage servers should be nearer to the site. So, and next parameter is groundwater table in the site should not be high. Site should provide sufficient light and air, and site should not be in depression. So, we are differentiating the site selection into two. One is industrial building and another one is residential building. For selection of a site for constructing an industrial structure, first thing we have to see is raw materials must be near to the site and labor availability. Site must have enough space for expansion, suitable disposable plant to treat the solid and liquid waste. Topographical features of site should not be affected the site selection. And some of the basic functions of buildings are should provide comfort to the occupants, should provide the occupants from natural calamities such as heavy rain, storms, etc., and should provide safety for the occupants and their valuables. And main important criteria for building is proper ventilation. The air and light should have passed through every room present in that particular building. So these are all some of the basic functions of building. So the different components of buildings which we are going to see is, first one is foundation, brick masonry, stone masonry, beams, columns, lintels, roofing, flooring, and plastering. So first one is foundation, which is also known as substructure because it is constructing below the ground level surface. This one is brick masonry, and this one is stone masonry, and this one different types of beam. This is wooden beam, and this one steel or iron beam, and this one is concrete beams. The next component of building is column. So in this image we can see the different columns here. This one is column, and we have already discussed about the beams. This one is beam, and this one is slab. So this one is a framed structure, and this one is, now next parameter is lintel. So this one is lintel, which is constructed above the doors or windows. And here first parameter we are going to discuss is there are two types of building. One is framed structure and another one is load bearing structure. In framed structure, the load transfer mechanism from slab to beam to column and then to foundation. And for load bearing structure, the direct load from slab is directly transferred to wall and wall to foundation. And here for lintel, this one is known as cut lintel. So this one is cut lintel which is used, this one is cut lintel which is used in framed structures. For load bearing structures we are providing this type of lintel for full buildings. Then roofing. So there are different types of roofings or A-frame roof, bonnet roof, butterfly roof, gable and valley roof, flat roof, gabled roof with dormer window, And different types of floorings are, this one is wooden floor, and this one is cement flooring, and this one is mosaic flooring, and this one is tiles flooring. And next parameter is plastering. The plastering is a process of covering rough walls and uneven surface in the construction of houses and other structures with a plastic material called plaster. So this one is plaster, which labor is doing here. And next main important topic we are going to see is foundation. So foundation, what is meant by foundation? It is a part of a structure which transmits the load from superstructure to the earth. So which means, so the load from the slab to the beam and beam to the column and directly to the foundation here. And you can see different types of foundation which we are adopting in this building. What is the purpose of constructing a foundation? The first purpose is to distribute the load coming on the structure to the ground, to support the structure and to give enough stability to the structure against various disturbing forces such as wind and rain, and to prepare a level surface for concreting as well as the masonry works. So if we are going to construct above the level surface without foundation, if it have any earthquakes, it will affect the structure. For that purpose, we are providing the foundation. And before constructing a foundation, we have to inspect the site. So first criteria is behavior of ground due to variations in depth of water table. So in every area, the water table is varying. So we have to first identify the water table, and next one is nature of ground by means of visual examination. So we have to see the ground, how much soil is there and any rock strata is there. These kind of things we have to identify in the particular site. And next one, movement of ground due to earthquake, landslide, etc. In this criteria, the main criteria is earthquake, because so we have 5 earthquake zones from zone 1 to zone 5. So initially, what type of zone the site is presented. So due to that, we are going to adopt this foundation. So and then landslide. Landslide mostly we are going to adopt in hilly areas. The building which we are constructing in the hilly region, we have to adopt this type of landslides. And next criteria is the properties of soil are studied by doing some basic procedure. First one is test pit are made up to foundation level. The soil is excavated and examined in the lab. So there are several studies we are doing for testing the soil. So there are different types of soil based upon their size. One is gravel, another one is sand, silt, clay. For gravel, the size of the soil particles which varies from 4.75 to 80 mm. For sand, the size of the sand is 75 micron to 4.75 mm. And for silt, the size of soil particle which varies from 2 to 75 micron. And for clay, the size of particle which is less than 2 microns. And next one, the bearing capacity of soil. What is meant by bearing capacity of soil? The bearing capacity of soil is defined as the maximum load per unit area which the soil will resist safely without any displacement. So for constructing a structure, we have to check the soil bearing capacity. The safe bearing capacity is obtained by dividing ultimate bearing capacity by factor of safety. The maximum differential settlement should not exceed 25 mm in case of foundation on sandy soil and 40 mm in case of clayey soil. You can identify this picture. There are differential settlement. You can see this image. So for a same structure, we are having 2 types of soil. One is here, you can see this one is sandy soil. The sandy soil which have good bearing capacity. And same here, this portion, we are having silty soil, and in this silty soil we have poor bearing capacity. So for a same structure we have two different soil profile leading to differential settlement. See here, in this bearing capacities there is sandy soil, there is no differential settlement. In silty soil there are poor bearing capacity, and so the differential settlement is occurred here. So see here, see this images also, here also differential settlement, and this here. So bedrock, so bedrock means existing layers, and this one is fill. Fill means artificially filled soil. We have to remove this type of artificially filled soil. So due to this filled soil, the different settlement will occur and the building will getting collapsed. And next one, way to improve bearing capacity of soil. The first criteria, increasing the depth of foundation. So due to the depth of foundation, the foundation will be getting stronger. And second thing, reducing the air space in the soil mass. So we have to avoid the pores present in the soil mass, and draining of subsoil water, grouting the soil mass, confining the soil mass. So draining the subsoil water means we have to remove the water present in that soil, and grouting means how high pressurely we are compressing the soil, and confining means we have to layering the soil in proper manner. And next we are going to see about different types of foundation. So first one is shallow foundation, and second one is deep foundation. So first one, shallow foundation. The shallow foundation, which means the depth of foundation is less than or equal to its width. It is defined as shallow foundation. What is meant by that? So the depth of foundation is less than or equal to its width. The room size, for example. So see here in this image, the depth of foundation is here, and this one is width. So the depth will be less than or equal to its width. So we are telling it as shallow foundation. In shallow foundation, we are subdivided into different types of footings. One is isolated footing, strip footing, and then one is combined footing. So in strip footing, we are subdividing into again simple footing, and another one is stepped footing. So isolated footing. So in framed structure, where several columns are to be constructed, isolated footing can be adopted. Why we are adopting isolated footing means the distance between two columns will be very high. For example, if you are going to construct a column here and another column will be here, so the distance is very high. So we can't adopt full foundation here. So we are pitting here separately and here also separately. So we are providing isolation here. So if masonry footings can be provided, steps are given and the foundation area thus increases. If concrete footing is provided, sloping is given on all the sides to provide sufficient spread, and the projection of each step must be half bricks thick. And next type of footing is strip footing. So this type of strip footing we are going to adopt only for load bearing structure. I already explained this one, load bearing structure. The load bearing structure, which means the load can be transferred from slab directly to the wall to the foundation. So wherever the wall comes, the foundation also will be there. So when good bearing capacity of soil is available, then this type of foundation is preferred as it is run throughout the wall. So in strip footing, we already discussed that there are two types, simple footing and another one is stepped footing. So in previous image we have seen about simple footing, and this one is stepped footing. The stepped footing means when the ground has slopes, the stepped footing are provided. For example, so I am going to draw an elevated image. So the ground level will be like this. So for that we are not going to fill the soil with here. So we are going to provide foundation will be like this. So this one is stepped footing without affecting the area landscape. We are providing the foundation here, stepped footing. So it contains two or more footings of stone or brick masonry and concrete bed below the ground level. So here, so we can see the brick masonry here, and this one is concrete bed. And then next type of foundation is combined footing. So in this combined footing, so where the space between two columns is so small, then this type of footing can be provided. So the distance between two columns, if it is very small, means we are going to provide only single footing, where we can adopt two columns in same footing. So this is known as combined footing. So combined footing are proportioned in such a way that center of gravity of load coincides the center of gravity of the foundation. So the load can be transferred from both the columns. So how much center of gravity we are providing here? So this is combined footing. And next one is mat foundation. So mat foundation where we are going to provide is a large slab supporting a number of columns. So for example, the area of build-up area is very much high. So in this area, so we are providing so much number of columns. And the span between the columns is also moderate. Very small means we can provide this type of foundation, mat foundation. So it is a large slab supporting a number of columns and walls under the entire structure on large part of the structure. A mat is required when the allowable soil pressure is also low. This one is also one of the criteria, which soil pressure is very low, or where the column and walls are so close that individual footing would overlap or nearly touch each other. So mat foundation are useful in reducing the differential settlement on non-homogeneous soil. Non-homogeneous soil means I have shown that picture for a single building. So here area, this one is an area, this one is a building. In same building we have two different soil profile. So two different soil profile means, so we have to adopt this type of foundation. It will helps to safeguard the building. So mat foundation are useful in reducing the different settlements on homogeneous soils, or where there is a large variation in the load on individual columns. You can see this image. So the build-up area is very high. So they have provided complete mat here. First reinforced mat. They have provided reinforcement here, and they have provided concrete here, and after they have to construct a column here. So we have seen different types of shallow foundation. Then we are going to deep foundation. So in deep foundation, where bearing capacity of soil is very low and hard strata is not available, and then deep foundation should be preferred. So different types of deep foundations are, one is pile foundation and another one is pier foundation, caisson or well foundation. Pile foundation. Pile foundation is an element of foundation used as construction. It may be driven into the ground vertically or with some inclination to transfer the load very safely, and the load transferred either by friction or by end bearing. So why we are adopting pile foundation? The soil bearing capacity is very low and we are adopting this type of foundation, and the load transfer mechanism either by friction. The friction means, so if you are constructing a pile here, this will be your soil layer, and the load transfer will be by either friction, the friction between your soil as well as your pile, and another thing, or end bearing. End bearing means bottom here, bottom portion is end bearing. So the friction, the contact between two soil layer as well as pile, and end bearing means bottom of the pile foundation. And pile may be of cast iron, concrete, timber and steel. Most of we are using concrete as well as cast iron, and timber and steel we are rarely using. And common types of pile foundations are driven pile, cast in situ pile and board pile. So different methods we are adopting for constructing a pile foundation. So here you are seeing this image is, this one is board pile. So board pile, we are constructing this pile in some other place. We are transferring from one place to here and we are hitting here. So the pile is entering inside. This one is board pile, and here this one is cast in situ pile. So what is that cast in situ pile? First thing, we are going to provide one mold inside, steel mold. This one is steel mold, which it is penetrating inside the soil layer here, and after completing the penetration we are providing the reinforcement. This one is reinforcement, and this one after completing putting the reinforcement inside the soil, and we are pouring concrete. So this one is cast in situ pile, and this one also one of the driven pile or board pile. So in this first lecture, we have seen the different components of buildings, how the site can be selected for industrial structure as well as residential structure, and different types of foundation we are adopting in the structure. So thank you.